These are drawings made by 7 to 10-year-old children solving arithmetic problems without resorting to symbolic algorithms. Could these pictorial frames be form of natural, spontaneous expressions of children these ages? We have also these pictorial expressions by children who did not achieve solutions for the same word problems. These two groups were differentiated by two ways of experimenting how to learn mathematics. How so? Before performing their pictorial frames by way of assessment, children of the first group had experienced arithmetic operations as actions arranging tangibles in order to solve daily life word problems. This happened at the closing of a project involving 1,053 students and 26 teachers along 8 months in a low-income neighborhood of Medellin, Colombia. Children in the second group, a control group, had experienced arithmetic operations as symbolic algorithms only. Such contrast confronts us with the fact that, quite likely, those former pictorial representations are not children's natural, spontaneous expressions. We considered such drawings as pictorial representations by children who have attained a proficiency in accomplishing a kind of specific action involving quantity numbers. Also, that this proficiency allows them to efficiently perform in problem situations within daily life contexts. We have adopted here Jean Piaget's approach about the meaning of an action as to what it is achieved through it. Notwithstanding, achieving such proficiency could demand continued experiences. These are certain procedural ways of acting in order to reach a definite goal. However, what is this of experiencing arithmetic operations as actions? By and large, we think of these operations as symbolic algorithms. From some time in history onwards, arithmetic actions could be considered separately from world-life events and, therefore, were symbolically formalized. At the beginning, though, they were factual actions undifferentiated from daily life events and performed with tangible quantities on a surface. In their quotidian surroundings as well, children experience situations involving manipulation of material quantities, whether continuous, for instance loaves of bread, or collection of objects such as cookies, pencils, etc. Today, symbolic algorithms are used to solve problems in several world-life situations. By and large, pupils learn to perform with the algorithms and later practice applying them. The difficulties for schooling that arise from this approach are sufficiently well known. Nevertheless, we need to consider the duality posed by this system between the algorithms on one side and the world-life events on the other. We shall take a look at this duality by means of a promenade about the implementation at schools of a learning environment of our design. This learning environment was experienced by Medellin's children. In the first stage of this environment, children experience arithmetic operations with tangibles within daily life events. In the second stage, experimentation is carried out with tangibles as quantities per se, not having any relation to daily life contexts. In the third stage, children solve word problems posed in quotidian surroundings. Thus, children will reunite again the two actions as one. Initial experiences are set in world-life events close to children's day-to-day. Either they are staged, for instance the game of elevenses, or narratives to be read. The story presents some quantities expressed with a name or symbol of number which children may recognize. The child reader would ascertain that in the story there is something to be done, finding a quantity unknown. There is a circle of action posed in this undifferentiated event like the one we see here. After reading the narrative, the child places herself in the stand of the characters to proceed to find the unknown quantity. the child reader herself has to perform the arithmetic action in itself, that is, making accounts. Now, such action is differentiated from the world-life event even though it depends on it. The circle of action, the arithmetic action in itself, is shown here. The action the child has to execute is in itself a whole means-goal circle, however dependent on the world-life event. Crucially, the child has to perform her action in correspondence with the course of the moments in the world-life event. Starting from the known quantities, the child is required to set up a frame of arrangement with tangibles on the surface. In this frame, each quantity will have a definite role in correspondence with the moments of the world-life event. Let us see moment by moment this process in the following example. Initial moment. The initial quantity is placed at this point in the story. Sequentially, the child arranges tangibles and counts them one by one. She already understands that those tangibles stand for any series of objects in the world. Transformation moment. It is the point in the story where a quantity transformation is mentioned. The child would effect a change in the initial quantity by means of this transforming quantity. The sense of the transforming action the child has to perform is expressed in the story either explicitly or implicitly. In this case, it is about taking out some eggs from the fridge. In the factual action, the arithmetic operation becomes a spatial arrangement of tangible quantities. Here we can see a setting in one-to-one correspondence between the units of the initial quantity, which is a quantity whole, and the quantity part that is removed from that quantity whole. Spatial proximity allows the child to readily notice by comparison the quantity remainder on her frame of arrangement. This is the quantity unknown. Final moment. On her own arrangement, the child becomes aware of the quantity remainder and counts it one by one with respect to the quantity whole. This with respect to is here spatial proximity. Finally, the child writes down the quantification as the goal reached at by means of her action in accordance to the purpose of the narrative. So far, we have not mentioned the reading comprehension of problem statement. However, these outcomes show that such comprehension is a necessary condition to undertake the search for the solution. The way of proceeding, arranging quantities as means of reaching at the goal of finding the unknown quantity, seems to be an anticipation by the child, an inference that if she proceeds in such a way, she will achieve the sought-for outcome. Such procedural way seems to reveal a linkage of sense between the two events, the occurrences in the problem narrative on one hand, and the arithmetic action the child performs arranging the tangibles she represents on the other. Participant children who did achieve solutions performed representations exhibiting interesting traits. These children represented the two known quantities either by means of pictorial forms or, some of them, expressing symbolically one of the two known quantities. Their solutions present different pictorial frames. However, what is salient here is that these children place these two quantities in a relationship, a link that in these drawings is no more, no less, than a procedural way of arranging the two quantities in spatial proximity. Let us notice the different pictorial representations. What is invariant in them is the setting of quantities in correspondence and in spatial proximity to compare them as parts of a whole, to finally bring forward and count the unknown quantity. These frames are expressions of a wholeness of action in this sense means goal. Crucially, the child has to perform her action in correspondence with the course of the moments in the world of life event. Such procedural way seems to reveal a linkage of sense between the two events, the occurrences in the problem narrative on one hand, and the arithmetic action the child performs arranging the tangible she represents on the other. Thus, there is no place for confusing the role of each of the quantities, whether they be quantity whole, quantity part, or a quantity to be shared as allotting by assignment. Such confusion is frequently observed in the outcome of children who work only by means of symbolic algorithms. This way of proceeding, which she already knows though, should be a schematization, a generalizing of the action she's had the opportunity to repeatedly experiment. In consequence, she's been able to link together certain procedural way of arranging quantities with certain goal to achieve. A factual action of complex structure is revealed in the above description both of the arithmetic action in itself and its relations to world-life problems. This structure, as well as the diversity of its linkages to world-life events, remains hidden underneath formalized symbolism. The teaching modalities relying heavily on procedural rules, as it is usually done, express the procedural ways and schemas of action of the adult who explains, instead of being the outcome of the child's own action as a whole goal means circle. This fact could explain well the low probability of attainment at school we face today. Arithmetic actions are part of children's world life and they assume their sense nonchalantly. Previous to their involvement with symbolic algorithms, children may experience with tangibles to attain thus an awareness of the arithmetic action as they're making under certain requirements in order to solve problems in daily life contexts. The raison d'être, the signification of this way of performing for the child will then be the outcome achieved through it in the way of a means-goal frame of meaning.